welcome to Kaelin-Tech lesson on VPNs. So the next couple of lessons are going to be VPN based. So this particular one is going to be a site-to-site VPN. I'll leave the topology on here for the moment, but the VPN will be between London SRX, physical interface for the tunnel will be GE004, to the Bristol SRX GE004. The loopback 0 interface on Bristol will not be available unless you go across the VPN, and I'll show you that. And the loopback interface on the London customer will not be available unless you go across the VPN, and I'll show you that. In other words, the London router will not be able to get to the London customer loopback, and the Bristol router will not be able to get to the Bristol customer loopback, therefore stipulating that it must go across the VPN. Okay, so you can pause it obviously at this point in time to just get an idea of the topology and get that configured up ready. We're utilizing is between the G04 interface, 004 interface on London SRX through to the Bristol SRX of G004, therefore meaning that the London router, the Bristol router, and the internal facing interfaces, the trust interfaces, are all running is, nothing else is. It's static routes so that we can prove this point for you of the VPN running correctly. So G004 to G004 is trust up to the customer, and G000 on both SRXs in the untrust zone. Okay, so let's go ahead and have a look at the configs, and I'll prove to you the connectability currently with no VPN. So we'll start with the London customer. So we'll do a log on a minute, normal credentials, and we'll do a show configuration display set, and it's a very basic configuration. So we have a login class configured, we have a login user configured, we have the SSH, we have the interface that faces the SRX, we have the loopback with the address noted in the topology, and we have a static route of just a basic default route telling it to go to the SRX for anything. That's the London customer. The London SRX, we're going to log on with root on this one. Okay, so we'll go to the CLI and we'll do a show configuration display set. And if you're using a default system, you'll notice that what you'll need to do is you'll need to put in place, as we're utilizing trust and untrust, you'll need a trust zone to untrust. Although there's a default one for that anyway. You will also need, obviously, a untrust to trust and an untrust to untrust, although the untrust to untrust is only if you're going to be have another interface and you need to go intra-zone. You will also need to set up your, at the moment it's very, very open, so you'll need to set up your system services, all your protocols, all for the host inbound traffic, and you'll need to put your G000 interface into untrust and your G004 interface into trust. Okay, as you can see, the loopback just has the ISO address, and it has a 333 and a 3333 as a 32, and we've got a static route going to the London customer via the physical interface. Okay, and that's it. That's all we've got on there at the moment. London router, again, very simple setup, very basic. Show configuration display set. So again, login class, user, SSH services, two interfaces, one to Bristol router, one to London SRX as it states there, with the addressing on there, loopback, net address, and the is protocol running in a very basic format. Okay, that's the London router. Bristol router. will be exactly the same configuration, but with slightly different addressing, naturally. So again, class, user, SSH, interface to London, as it says there, interface to Bristol SRX, the ISO address, the loopback address, and the ISIS protocol configured. Okay. The Bristol SRX is exactly the same as the London one, but again, with the obvious addressing differences. So we have our zones all set up. We have our interface in untrust as it should be, and the interface in trust. And we have our static routes 200, 200, 200. And the Bristol customer is going to be like the London one, but sorry, tried typing that a bit quick. It's going to be like the London one, but again, with different addressing. So let's have a quick look. Login class, user, SSH, physical address, loopback address, and a default route going to the Bristol SRX. That is the basic configuration. So from the Bristol SRX, what we're going to do is we're going to do a ping 200.200.200.200. Okay, and we can ping that. Okay, from the London SRX, can we ping the London customer? Ping 100.100.100.100, and that's fine. Okay, so to prove that we will be going across the VPN from the London router, ping 100.100.100.100, no route to host. Oh, sorry, pressed the wrong key again. And ping 200.200, which is the Bristol customer, also no route to host. From the Bristol router, no route to host, and no route to host. So there's no communication across that at all. So let's start with the London SRX, and we're going to go into edit mode or config mode. Okay, so let's configure up the site-to-site VPN. So what I'll do is I'll configure this end, and as the other end will be almost identical, I'll just copy and paste across to that to speed up this lesson. Okay, so let's get on with the configuration. So the first thing we do is we set our proposals. Okay, and this is phase one. IKE is phase one, the Internet Key Exchange. Okay, and this is for the actual setup of the tunnel itself, not the data going across it. That's phase two. So this is just phase one. Okay, so we're going to go to proposals, and we're just going to call it K-Ling IKE proposal, and the authentication method is going to be pre-shared keys. Now we can use the up arrow for the next few lines because it's all the proposal section. So now we're going to go to the Diffie-Hellman group. So DH group, and we're going to utilize group 2. And the authentication algorithm. What do we have available here? Okay, well, we're going to use SHA-1. And the encryption algorithm is going to be AES-128-CBC. And the lifetime in seconds, and we'll put it quite high because this is just the actual physical tunnel itself, or the tunnel, should I say, the phase one. So let's put this at 86400. Okay, so that's the actual IKE, sorry, not the IKE part, the proposal part itself. Then we're going to move on to the actual policy. Okay, so we can still do this, but we'll go back to here and we'll do policy and we'll call it Kaling dash IKE dash policy, and we need a mode, and we're going to use main. Now you have two modes, you have aggressive and you have main. Now I'll do a little PowerPoint presentation later on, not in this lesson, but in another lesson, showing the differences between main and aggressive. But what you need to know is that aggressive is usually utilized for dynamics. So in other words, people that you know, so somebody that's using a client that logs across like a work, somebody working from home, etc., etc. And the reason for that is because of the 6 point negotiation. Aggressive only uses 3 of those, main uses all 6. So therefore the authentication process isn't as long, because you're basically stating this dynamic person using a client is a trusted individual. So we use mode main. Then we call our proposal. Okay, and if we look at that, proposals, and if we look at that, it will list us our proposal that we've already created. And there it is, so we can just put that in there. Now we need to put in our password. Okay, so we utilize pre-shared key, as we noted, but we want it in ASCII text, and we're just going to put in their password. This is the actual password that you're going to put in. You're going to want something a lot better than that, but I'm just utilizing this to show you. Okay, so this will be what will be negotiated between the endpoints and has to be agreed. Now we set up the gateway. And we'll just call this Kaling dash GW. Okay, and we'll have a look at what options we've got available to us. Well, we want the actual policy in here, so we're going to utilize IKE policy, and again, it'll be there, look, for us. Okay, so there's our policy. Now we need our peer address. Now we're on the London SRX, so what we can do is let's have a look at our topology again. And which interface are we going to? Well, this one here, G004 on the Bristol SRX. So we want 192.168.2.2 in there. So we're going to put in 192.168.2.2. Okay. We also want a dead peer detection. And we will want to put on there always send. Okay, and the reason we put always send on there is because even if it's dead, we always want to, it'll show as dead, but we still want to send because it might bring it up when it sends interesting traffic across the link. Okay, so we're going to put always send in there, and we have to put obviously the external interface, which in our case is G004.0. Okay, now because that's all the IKE phase 1 side, so that we, just in case we lose something, we can always do a commit check here, but it should commit okay. So we can commit that side of it, and that's the phase 1 complete. That's phase 1 to bring up the actual tunnel itself. Obviously, you've got to do the far end yet. Now we move on to phase 2, which is the ipsec side, which deals with the data that goes across the tunnel. So we do a set security ipsec. Again, we start with our proposals, so we'll call it Kaling dash ipsec dash proposal, and we are going to utilize a protocol of ESP. Okay, then our authentication algorithm is going to be, and let's have a look at the options we've got. So we're actually going to use SHA1-96. And our encryption algorithm Let's have a look at what we've got again. Well, we're going to use the same as we used before. We're going to use 128-CBC. And we have our lifetime in seconds. Now, this is the data, so it needs to be a lot shorter. So we're going to use 3600. Sorry, 3600. And that's our proposal. Next, obviously, we move on to the actual policy. So we're going to go back to here and we're going to put in their policy, and we'll do Kaling -ipsec -policy. And let's have a look at what options we've got again. Well, on this particular one, we're going to use perfect forward secrecy. Let's have a look at what we've got under that. And we're going to use keys. And again, it's going to be group 2. And then we call our proposals again. And what have we got? Well, we've got the one that's already there, look. So we call that proposal. Now we set up the VPN side of it. So again, sorry. So let's have a look at what we've got here. What do we want to do here? Well, we want to bind our interface, which is ST0, and we'll put in there .0. Okay, so that's the interface. That's the special interface that exists for VPN connectivity for the data side of it. It's important to note that the ST0 interface does not have to be in the same VR as the physical interface, but you must make sure obviously there's policies that allow the flow of traffic between the different zones. Okay, but in this particular example, we're just going to put it in the trust zone anyway. Okay, so we've bound the interface. Now we put in there our which will be listed for us, and there it is there. And we also have to put in our ipsec policy, and that will also be listed for us. Again, you can see it in the list. And we are going to establish our tunnels immediately. What that basically means is they're going to be up all the time. Okay, now it won't let us commit that yet because we've done the ST or we've included the ST0 interface, and what will happen is it will say that that interface must be configured first. So let's go ahead and configure that particular interface. So let's do a set interfaces ST0 unit 0 family inet address 192.168.1.49/30 because we'll need 50 at the far end. Now if we do a commit check, okay, so we can commit that. Okay, so what we've got there is we've got the VPN configured. We've got the phase 1 and phase 2 configured for the site to site. But what we have to do is we have to make sure the routing is in place for all the information that we want. Now we know that the Bristol customer loopback is 200, 200, 200, 200, but at the moment we don't know how to get there. So for example, run show route 200.200.200.200. It doesn't know how to get there. So if we do a set routing options static route 200.200.200.200/32, and the next hop is going to be our ST0.0 interface. Now, what we've got to be careful of here is that the return traffic will also be utilizing this network. So this 172.16.16. So we need to include that as well. Okay, so let's go ahead and include that. So set routing options, static route. Now, normally this would probably be taken care of with some dynamic routing, but I just want to show you this for if you want actual specified routing. Okay, so we're going to put in there 172.16.16.0/30. So that's that particular network, and that also next hop is st0.0. Okay, so we can commit that. Now, we said we were going to put that in the trust zone. So now we have to do set security zones, security zone, trust, interface, st0.0. So let's go ahead and commit that. Okay, so let's have a look at our, let's exit this first and we'll do a show configuration display set. So we now have our trust zone has st0.0 in there, st0.0. It's got system services all, protocols all. As I said before, the untrust has got the interface that faces the customer. Again, system services all under host inbound traffic and host inbound traffic protocols all. And we have our routing to st0.0 for the two networks that we need. Okay, so what we can do now, and what we are going to do, is we are now going to copy this over to the other system, okay, to Bristol with the changes that are going to be required, obviously, because both ends have to be the same. Okay, that's the best way of stating this. So let's do it a few lines at a time, because for some reason this doesn't like too many lines being completed all at once. So there's the first four. Let's go back to here again. Doing it this way ensures that you've got it the same at both ends. Okay, and here we've obviously got to type this in, and in here we're going to put a password, because that's what it was at the other end for the actual password itself. Now we can do the next two lines, because we've got to make sure that we put the London address this time. This is the Bristol one, so we don't want that as the peer. So the address this time will be, so if we have a quick look at the diagram again, 192.168.1.2. So it's 192.168.1.2. Now we can go back to the London SRX and we can do our next configuration, and we know the gateway interfaces for the same, so we can copy these four lines and we can paste those in, and we can copy the next four lines, paste those in, and we can copy the VPN section. Okay, and we can paste those in. Now we should be able to do a commit check, although again, because of the st0.0 interface, right, so set interfaces st0 unit 0 family inet address 192.168.1.50. If you remember, the other end was 49, and that's a /30. Okay, so now we can commit that. Again, we do a set security zones, security zone, trust, interfaces st0.0. Okay, and now we have to do our set routing options, static root of 100.100.100.100 / 32, and the next hop st0.0. We also need to do a set routing options static root of, and let's go back to our topological diagram. We need this network here, 10, 10, 10, 0. So 10.10.10.0 / 30. Next hop is going to be st0.0. So let's commit those changes. Now, the first thing we can do to see if the tunnel is up is we can do a show security. If we want to have a look at phase 1, we use IKE, the Internet Key Exchange, and we have a look at the security associations. Okay, and we see its mode is main. There's the remote address, which is what we put in, and look, it's in an up state. Okay, so now let's have a look at show. We're going to look at phase 2 now, security, ipsec, because we know that's phase 2. This is the data. And again, it's the security associations. And there they are. That's really good. It's ESP. It shows us all our encryption algorithms and the gateway address at the far end. Okay, so we know that's working. Let's just have a look at the same from London's perspective. So if we do a show security IKE security associations, it's up. And if we do a show security ipsec security associations, they're up. So from the actual SRXs, what can we do here? Can we do a ping? This is London, so 200.200.200.200. Yes, we can. Okay, but we know from London router we can't. So we know we are going across, or must be going across, the VPN. If we do a show route 200.200.200.200, it's still not there. So if we try to ping it, no route to host. So we are definitely 100% going across the VPN. Okay, so from the Bristol SRX, can we ping 100.100.100.100? Yes, we can. Can the Bristol router ping it? It won't be able to because the route isn't there. So we're confirming again that it's definitely going across the VPN. So if we do a ping 100.100.100.100, no route to host. Okay, so we absolutely cannot do it from there. So the telling point is, can we do it from the Bristol customer? Because that's where we really want to be doing this from. So let's have a look. Ping 100.100.100.100. And yes, we can. Okay. So now we'll do the same from the London customer. Can we ping Bristol's loopback interface, customer interface? So ping 200.200.200.200. Yes, we can. Okay, and to prove that, we can do a trace route 200.200.200.200. Okay, and as you can see from the middle one there, we go across the VPN address. That's the address at Bristol. Now, if we go to Bristol and we do the same the other way, not the SRX, sorry, from the customer, 100, 100, 100, 100, and we get the 49 address. Okay, so we know those are the ST0 interfaces, and that is how easy it is to do a site-to-site VPN. The next VPN we'll move on with is showing you how to do a dynamic VPN using aggressive mode. Thank you. Any questions, just let me know. Thanks. Bye.